Good morning, good evening, and good afternoon to our viewers, and welcome to the next episode of Groundbreakers Transforming Geotech. Today, we're joined by Brendan, a very experienced veteran in the transportation sector, and he's currently the rail business lead for Arup in Denmark and Scandinavia. Today, this episode will give you an opportunity to dive into the rail industry, transportation infrastructure industry, and we really get to learn about Brendan's experiences and really talk about how this industry is transforming in the future and what really he sees as the future of the industry, the people, the community. So Brendan, thank you for joining us. And your career has been quite diverse. You worked on many urban infrastructure projects across Europe. So let's start by you sharing initially a bit about what drew you to specialize in the rail and transportation sector, and how did this passion spark?
Sure. Well, first of all, thanks for having me. Yeah, I mean, my specialism, I'm a geotechnical engineer originally by background. That's at least where I started my career, but I was working on the contractor side. So yes, we were doing technical design, but maybe not as much as you would typically if you're in a consultancy engineering. But I very quickly moved over to the Crossrail project in London, where my focus was around the monitoring and understanding ground movements and ground treatment, mitigations, all of this associated with major underground works in an urban environment. So that really led me into the world of tunneling and underground spaces. So I suppose if I have an expertise, it's probably where it sits best. But since then, my evolution has taken me really into the kind of wider understanding of the construction and design of large-scale projects, particularly underground projects, metro projects, and things like that. So I'm now at a more kind of multidisciplinary design management stage. So understanding that holistic picture of a large complex projects about how different actors and different pieces of projects come together in order to create what is eventually a big new urban piece of transportation.
Wow. So I think through your experiences, you really went to specialize in underground design, and now we reached the management level where you're handling teams, handling communication amongst teams, and working on the design as well. So picking up on that, so you're working a lot on the engineering for these critical projects where I think in college you learned about the iron triangle, where you have to manage the time, budget, and value, and you're managing the people on the project, which is again a big challenge. So how do you balance that out? Like, how has that experience been for you in the industry?
Yeah, it's difficult, and we often on very large projects we often try to separate out a little bit what we call the hard project management, looking at the kind of the resources, the people management, the financials, commercial aspects of our projects, and the design management, where we really focus on design as opposed to the management. So really that kind of integrated multi-disc design. I currently, on the role I have, it is still a little bit of both, but the most important thing to be able to do that successfully is having the right team behind you. So a design manager isn't there to make all of the design decisions. They're there to help design decisions be made. So you need the right discipline leads, whether structural engineers, mechanical engineers, geotechnical engineers, all contributing into what is then should be hopefully an easy decision to make at the end of the day. So design management really is about having the right team then sitting below you to help the overall design progress. But then the project management can be something easy, and it can be incredibly difficult depending on the state of the project. So right now we're in a good place in the project I'm on. The relationship with the client is hugely important to that. We have a joint venture here with Covey, so it's an Arup Covey joint venture, and again that relationship can either mean it's an easy project to manage or a difficult project to manage. In this case, it's a very easy project to manage because we have a really good open joint venture, open partnership with Covey. So it just makes things like resourcing and commercials and all of this aspects relatively straightforward because we're all in agreement. It very much depends on the project.
Yeah, and I think project, everything is different. And your point about the team and having the right team and a diverse team was very important for people who are going to manage projects in the future, and having experts in each field, because you need a good structural, you need a good mechanical, a good geotech designer to work in the design team as well. So, like you mentioned Crossrail, you worked on the M5 line as well. So from a few projects, do you want to maybe discuss a few highlights of these projects? What were some new wow learning moments or some unique challenges that you anticipated or experienced?
I mean, Crossrail was full of them. So I mean, Crossrail, I was there during the, I joined just at the point when we were getting ready to start launching the tunnel boring machines, and where we were launching them was straight underneath. So we started launching them right next to the mainline railways that's coming out of Paddington Station in London. So it's one of the major trains for all trains running west out of London. And the tunnel boring machines had to go underground. We were starting very shallow and immediately turn underneath all of these tracks that come straight out of the station. And we were doing that just in the lead up to the opening of the Olympics in 2012 in London. So there was absolutely no way we would be allowed any disruption whatsoever. So everything had to function perfectly, because the idea of causing any disruption and having to stop, for example, a couple of the lines coming in because there was excessive movements as a result of the tunneling works, that was impossible to even contemplate just politically. So the effort that went in to ensuring that we had a monitoring system set up, running, reading everything properly and interpreting the information properly, that was huge. And it was many a long weekend night working there to make it happen. And it was one of those situations where if we didn't get this sorted by Sunday night, then on Monday we were going to have to stop the machines. But in the end, we got it up and running. Everybody was happy. Network Rail, the operators of the lines, were happy. Crossrail, the client, was happy, and we got to get the machines to pass under without any disruptions. So I still remember the nerves of all of that, which I thought was really fun. Quite exciting. So I think nowadays all of that would be done quite differently. It was a lot of Excel spreadsheets and trying to automate a download from databases onto spreadsheets to then do some kind of interpretation. Thankfully, I think we've advanced a little bit since that time.
Yeah.
But I'd say moving to M5 or the Copenhagen Metro in general, something that now on M5 it's designing a whole new line, and I now get to be part of a design team at a much earlier phase where we are defining the project. We're not anywhere near construction at this point. At the moment, we're trying to define what a station looks like, exactly where it's going to be placed, and what impact that has on the community around it. So a lot of the work now is with our architects in our team, and that's fascinating. It's a completely different view of the world of infrastructure that I would have had on Crossrail, which is all about building tunnels and shafts underneath the city. Now we're trying to work out how we can positively impact a city for the next 100 years, 150 years, 200 years, and try to change the dynamics of a city just by our design. And that's just a fascinating thing to be part of.
But I think that's a huge challenge in the way you framed it, because I don't think a lot of people really understand the long-term impacts of even a small change in design on these critical projects. And the M5 will, like you said, be the infrastructure lasts hundreds of years and will be super impactful to the city. And I also found it very interesting on how on Crossrail you guys were literally waiting for the spreadsheets to come on time and being ready on Monday morning. And now you've reached that stage where you're actually seeing it from like 5 steps back from the planning phase and being like, okay, this is how we do it. This is what we're planning. This is what the architects think. This is what the design engineering team thinks. This is what the community thinks, and really bridging those ideas together to make ideal or close to ideal infrastructure. Cool. So my next topic of discussion would be, I think the integration of systems, data sources, and also integration of communication on these large projects between architects, construction, design, monitoring is pretty critical. So how have you seen that evolve in the past few years, and where do you see that aspect of the business going?
I mean, it's completely changing. And because it's changing so much, everything we do is quite new. It seems like every time you walk onto a project, someone's got a different way of doing it now. which is fun. It's also a bit scary sometimes, but I mean, absolutely, it's evolved massively. I mean, we've, just a few years, we were all very happy with the old school project-wise way of collaborating with documentation or drawings, CAD or Bentley systems, these kind of things. But that was the kind of the basic level, just to allow a certain amount of collaboration within a drawing environment or within the space environment. That's obviously evolved, looking specifically to begin with, at least in the world of BIM. That's evolved a lot now. We're using Autodesk Construction Cloud on the project here, and at first I think it scared everyone a bit. It's a bit new. There's a big learning curve for our digital teams, for all of our teams, really, our BIM teams, trying to understand how does it work, just because it was a bit of a new tool for us. But now we can see the power of really integrated model coordination at this early design level. It's fantastic. It's a useful way for people like me who aren't necessarily the ones really deeply involved in the BIM and the digital side of it, to get access to these models and be able to understand them and understand how our different models from our different disciplines, the architectural, structural, the mechanical, electrical models, are all coming together in different ways. And I'm able to now go in there and understand and see where there might be issues or where some of the clashes might cause a problem further down the line. But that's specifically on the kind of BIM side of it. I think in terms of the collaboration and data collaboration, that's just generally for the project. That's where we've taken really big steps to try to do things differently, using GIS-based systems to share project information. So the most up-to-date system, project information is always accessible through a type of web portal, ideally with a GIS kind of background, so it's location based, especially for long linear infrastructure projects like the ones I work on. Being able to understand the documentation or information about a particular area, a site, we can go there literally using a map, as opposed to trying to go through a folder structure, discipline based or location based. So it's just a lot more accessible, and we know that everyone is using the most up-to-date information because it's all automated, and as alignment gets updated, then the whole system gets updated, etc., etc. So having that accessibility, especially it's on a project, it's not necessarily the design teams we need to worry about. They tend to be pretty good at this, as they're trained at making sure they're using the most up-to-date knowledge, the most up-to-date drawings from other disciplines. It's the other disciplines that sit around a project, the ones who are doing the environmental reports, the noise calculations, these other things that need to be done in terms of engaging with the communities, utilities, etc. There's so many other disciplines that aren't directly involved in the design of the project, but need to understand the latest design information. And they can all get that through the same place. And we're all working off the same thing, and it's very easy and visual. So that changes the coordination. It makes my job as a design manager an awful lot easier, I think, as well. So it's quite exciting.
Yeah, and I think BIM's been one of the big revolutions, like you said, as a technological boost, because like a digital twin could be a LiDAR, a drone 3D model of an area, but what we can do with BIM and the products through Autodesk, and those really help you like see what's going on and actually look at the construction and the progress in the design day by day. And even for monitoring now, moving on from Excel to like online platforms where you have GIS enabled, you not only have one type of data, but multiple types of data. So you're not restricted to this like sensors. And I think that kind of stuff really just gives people a bigger idea of what's going on. It's like your Apple Watch now. Before you had to go and get your heartbeat with a stethoscope, and now you have all your steps, your heartbeat, your blood oxygen, everything coming from one device. So you're fully aware.
One place.
Yeah.
Exactly. Yeah. And that's what we try to do on the project. We've created that kind of a system on our project here. It's obviously tailored to the needs of our project. A web portal where we can get project management information about hours spent, resourcing, all of that, but then also design information and so on. So it's just a useful place. I come in the morning, that's the first thing I open up. We even have a little chat bot, which is a project related GPT based kind of specifically based with project information, so I can find out stuff about the project. It's all there in one place and just really easy to use, so it's very helpful.
Yeah, but I think the chatbots, large language models specifically trained on your project data are also pretty helpful because they analyze stuff really, really well. Yeah. I think, like, I was playing around with GPT for advanced data analysis, and it was plotting stuff for me and analyzing like books. It was like,
Yeah.
it's worth it.
That's amazing.
Yeah.
Yeah. I mean, this is certainly not my area of expertise, but I've been fascinated to watch how a few of guys on our team have been playing around with this. So they've created this chatbot, but it based, like you said, it's based on all the project information. And it seems like, just from what I understand about it, the trick has been getting the background prompts right so that it gives the type of answer that we on the project would need, and it structures the answers in a way that, in a logical way that makes sense to how we would need it. And I can see that now. If I ask a question, it builds an argument exactly in the way that I would want to build an argument if I have to go and answer a question from a client. So I can now get a question from a client in an email. I can literally write that question into chat GPT and I can just copy and paste the answer back. And it's written in a really structured, clear, easy to understand, but very concise way. It's just remarkable. I mean, that used to take us hours to do. So
exactly. Yeah.
And more time for coffee. It's great.
Exactly. And I think it's giving us more time, and it's also letting us think on the actual problems that could be there on a project as well. Like, for replying to emails, etc. It also gives you sometimes, like, when you use these tools, especially when it's like trained and it's not the generic model from like Gemini or ChatGPT, it knows your platform, so it gives you insights that you wouldn't think about, because you have like 5 people running after you. That's literally just looking at the information, and of course you can add your own inputs and verify the answer.
Yes, of course.
So I think my next topic would be a bit more on your experiences at Arup on the geotech side. So as a geotech engineer by training, what got you into the exact design phase? What interested you about the design phase, and what was your experience like being in the field? So like we briefly touched upon it at Crossrail, but maybe in your younger days, like before that, like what was your learning? What was your growth? What was your experience?
It's a good question. You're probably going to expose me here as not a very good geotechnical engineer. I was pretty young still on Crossrail, but what got me into it? I mean, I did always, for whatever reason, I always found geotechnical engineering, or at least I think I was good at it, or I got it at university. That always helps a little bit because you have a bit more confidence maybe with it. Whereas the structural engineering, it wasn't that I was bad at it. I just didn't quite get it in the way that I saw some of my colleagues really, getting into it. So, but it was almost more by chance. When I graduated, I took a job in Spain with a construction company, with Ferrovial, the contractor, in their technical office, and it was in their geotechnical team. So that kind of work was doing a bit of design work on some projects, and also doing a bit of tendering work, trying to understand the maybe geotechnical risks associated with a project, so that they could understand that and build that into their bid for a project. But also a good bit of design work. But that was quite short-lived. So my geotechnical design career was only about 2 years, and that's when I moved over to Crossrail, where it was still technical, but it wasn't necessarily design. So that was that kind of interpretation of what's happening on site, trying to come up with quick solutions to react to problems that we have on site, particularly around, it's all the ground movements, asset movements, where buildings are moving, where train tracks that were going underneath are moving, and all of this, and trying to come up with solutions to mitigate against that as quickly as possible. So that's really fun. I mean, in terms of an evolution, to any young engineers, I would always advise spend a bit of time out on site doing that if you are a designer. I mean, other people stay in the kind of construction side their whole career, and that's fine, of course. But for those who do go into design, I think the advantage of spending time on site and understanding how the construction impacts things, and how sometimes you need to react very quickly to problems or things that you didn't necessarily expect. I think that's a great skill to have, and just useful knowledge, because later on when you go back into the design house and you're looking at a project that's going to be built 10 years down the line, understanding what those possible consequences are really impact how you approach the design. So I think that's just a really useful development thing to do.
Yeah, and I think that's a really important advice, because like the first thing we were taught in school, like in our stores class, was like the ground everywhere is different. And until you don't face the challenges, until you don't see it happening in a real project and you're there to solve that problem, like on CAD or on whatever you're using, like it looks good, the design, but when you actually start constructing the settlement, the second you start drilling and there's lateral movement, you're like, okay, let's verify this. Yeah.
I remember as we were, so when I moved over to Copenhagen in 2014, I was working on the City Ring in Metro, it's now open, so M3 it's called. The tunnel boring machines had started, so I was following the tunneling works. And we were coming up to one area of the city where there was a lot of talk about the gravel that was in the ground.
Okay.
And I was like, oh, what do they mean? And there was a lot of concern about this because it's an old glacial valley basically in the ground. So you can't see it at surface. At surface, like everything in Denmark, it's flat. But underground, there was this apparent valley, and I saw it in the drawings in the long sections. But you don't really know what that is. I mean, we had values, we had geotechnical, design parameters, but until you see it, you don't understand it. And we were excavating one of the station boxes in this area. So I went over to the site just to take a look. People were saying you should go and take a look at this stuff. And it's amazing. They had a massive excavator coming in, digging the ground, and as it digs out, it's just like being on the beach with saturated sand. Everything was just flowing back in. It was flowed. It looked like liquid. And I was then thinking, how are we going to get the tunnel boring machines to come into this? It's going to be so your perception of the risk just changes when you actually see it and you actually start thinking, how is this going to work? And now this project, we have an area where we're going to go through a similar set of ground. So now I know what this stuff is like, not just what the parameters are on a piece of paper. I know what it's like, and having that knowledge or having that experience of it really helps. Especially like you said, the ground is always different. So the more you can actually see of it, the much better you will understand what's going on.
Yeah, and I think that whole M3 experience is probably make and even the TBM team, managers team's life a lot easier. And when you're drilling that TBM, it's an expensive machine. It's a very critical process. And I think we were working on a Procure TBM, and like the whole thing there, like there's like 100-page like presentation that we built on like the amount of parameters we need to monitor and the kind of design we need to make for that. And I was like, okay. Even building the software for this is so complicated. So like monitoring the TBM on site is more complicated. And then when you're on a real world site with challenges like the gravel going in when an excavator is taking it out and you have these machines running through, it's like, wow, even more complicated. Exactly. So
I mean, the trick with TBM and monitoring, but the kind of important question to ask is, what is it that you're trying to understand, not what you're trying to monitor? Like you said on a TBM, there's so many data points you can monitor. Everything is being monitored on a TBM and on the surface, and almost everything in between. But the question is, what is it that you're trying to figure out? So, what you talk about the experience from M3. I think one of the best pieces of knowledge that we got out of M3 and the previous metros as well in Copenhagen was the fact that we actually don't get as much ground movement as our calculations and our assumptions about the ground would imply that we should be getting. We're expecting a certain amount of volume loss and therefore a certain amount of settlement of surface, and as a result our tunnels were quite deep. But from all of this tunneling that we have now done and the advances in EPB technology for tunnel boring machines and these kind of things, we're not really seeing that level of settlement. So we are now more confident as engineers in this early planning design phase to say, let's raise the tunnels up. Let's not be so deep. And what's the advantage of raising the tunnels up is that you raise the stations up. And if you raise the stations up, you don't need to dig down so much. It's cheaper, less carbon, a lot less concrete, and a much better passenger experience. Passengers don't need to, make their way down to the platform. Passengers can just go down to a platform really quickly, straight from surface. So this is one of the biggest learnings that we've gotten from, thanks to monitoring, thanks to understanding and being able to justify this with data. We can say, you know what, we're actually pretty confident now. Let's raise everything up. I think that's a challenge for all projects now when we have tunnels in urban environments. Do we need to be as deep as we are? And what is it that's pushing us down? And if it's about ground movements that's pushing us down, what's that based on? And do we have data that might be able to suggest, well, maybe we don't need to be so conservative. Maybe we can go back up. because that's money, carbon, and a much better passenger experience in the 100-year life of the project. So
Yeah, but I think that's a great
to set.
Yeah, and it's a great point that like if you can save carbon, if you can save money for the construction team and make it easier for the passengers, what else do you want? And something like as like simple as monitoring, not simple, but like as a concept as monitoring, and what you said, like really understanding what you need to monitor and understanding a site can save a lot for different parts of the project. So yeah, talking a bit about monitoring, so there's a lot coming up on INSAR, a lot coming up on satellite monitoring. We're using crazy types of drones, laser scanners, of course, the traditional geotech instrumentation sensors. So how do you see these different technologies coming up, and how are they impacting your lives as designers, as people running projects and going for projects?
Yeah, it's a good question. So a lot of us on this project now, for example, we have experience of the Crossrail types with hundreds of thousands of sensors and millions of pounds of money spent trying to gather this information. But trying to understand, is there not a much better way of doing this going forward? So we're at the point, or we will be shortly, of beginning to specify the project for construction. So writing all the specifications, including how the project should be monitored and what is the most efficient way of doing this. And that's where we are starting to look at different ways of doing it, and INSAR definitely being one of them. And it all comes down to the type of information we get, the accuracy of that information we get, versus the risk we see with, the reason for doing the monitoring is related to risk most of the time.
Risk.
It's to understand, first of all, are we getting the same movement that we thought we would be getting? Are we getting more? Are we getting less? And then, if there is excessive movement, whose fault is it? When did it happen? That's the reality of it. It's a big question. If you damage an asset, you want to know why it happened and, well, who's to blame, effectively. Yeah. So that a lot of the time, that's what determines what we have to specify as a monitoring. So that does it provide us with the information we need in order to be able to make decisions, whether it's a construction decision or a risk or a cost decision. So I definitely see INSAR, yes, absolutely. We're already talking about it. And for long linear projects, it just makes an awful lot more sense. If it does give us the quality of information that we want, then that would make sense. Because you can, take your snapshots over time and understand what's happening over time. Visually, it's a very useful tool as well, and certainly should be a more cost-effective solution to having hundreds of people going around taking readings on pins for weeks on end in cities. So
Exactly. Yeah, and I think INSAR, along with the different types of satellites that are launching for multispectral, telling you vegetation, and then even IoT coming in. So like reducing, like once you've installed these sensors and stuff, they're just giving you real-time data on your platform is really now making our industry as well becoming like the tech industry, where there's an innovation every few days. Now construction and design and even civil engineering is coming to that stage, whether it's on the design with BIM or it's on sensors or it's on IoT. We're really innovating and getting those sparks on at a pretty interesting rate now.
Yeah, I'd say an area that we talk about, and it's been attempted to some degree, but so what happens is you have these technological developments, looking at data at the moment in particular, and the advances. Now that's one thing, but then the question is, do the contracts follow? Are they able to follow at the same kind of rates of change as we're dealing with data and how we manage that? So something that we talk about a lot in the world of geotechnical engineering, the observational method, right? So leaving a certain amount of design open depending on what you observe on site. It's a very simplified way of describing what the observational method is, but that's something that we're really keen on and we love as designers, because it's a design that reacts to what we see, as opposed to a more conservative design it and then it doesn't matter what we see. So it allows that kind of flexibility on site, and the only way to do that is if you have good data on site. So that requires more monitoring and better monitoring. So in an ideal world, we would have a situation where you could quickly go from monitoring to analysis to solution, but very quickly, because one of the problems within contracts and within the observational method is the time needed to do that. If you do come up with a solution, the approval process to get that solution verified, accepted, etc., by the time you've done that, what you observed 4 months ago, you're way past it. You know, it's just not worth it. You just put in 4 extra props, and that's just the way it is. It's so having a system set up contractually and for verifications and to automate as much of this as possible between what you observe and what a new solution is, and getting that approved so that you can actually act properly on observations. I think that's going to be an interesting development in our industry that I hope will see.
And it hopefully comes in the future. I think that just gives a bit more tech sparks, and I think my head and our viewers had to see like how, okay, this is something, taking the observational method that we also hear discuss a lot when we propose monitoring schemes, to really bring that into the real world with the help of technology, automation, even maybe some generative AI, machine learning algorithms on the current design tools, or build new design tools that, okay, what they really need is data, analyze that data, give 3 proposed solutions, the engineers do some analysis, pick the best solution, propose it to the contractor. They're like, okay, this is a change in budget, go ahead, make a change. I think something like that would change the game.
Yeah. Sounds good.
Easy to say it.
Wishful thinking to some degree, but exactly. I mean, that's it. That's what we would like.
Exactly.
But this is where, you know, contracts play an important part of that, of understanding the trust in that and the willingness to accept that and open up to that, understanding the possible gains from that. I think that'll be important.
Yep. And I think getting, again, the whole people, like contractors, the designers, the construction companies, and even the structural engineers and geotechs all together, and really, it'll take time, because you're working on projects that directly impact nature, the environment, and people's lives. So you don't also want to take a risk with something new that you've never tried before.
No.
Yeah.
Not.
Yeah. Cool. So I think that was a great episode. Some great insights and experiences at Crossrail, M3, M5 in Copenhagen. If you guys ever go on one of those lines, you can remember that Brendan had a contribution to make there. And I also think we had some interesting discussions on geotechnical engineering, a bit on monitoring, design, managing large-scale projects, and the observational method, I think, was something interesting that we brought up at the end. So thank you so much, Brendan, for joining me today. It was great talking to you, and thanks for the unique close-up project insights too.
Great. Well, thanks very much for having me. It's been fun.
Thank you.